everybody? It's Tyler here at Space City checking in with 4148Z. Well, this is average this year, but not so average of a team. This is an absolutely fantastic package mechanism that they have here. This whole robot looks phenomenal to me. They got this awesome back clamp we'll be talking about a little bit more on here, but just look at overall their packaging they have, all their electronics down here below. It's only a 10-pound robot. I couldn't believe that when you all told me that as well too. So can't wait to dive more into what this robot is bringing here for high stakes coming up here on Pits and Parts.
This video on fun is brought to you by viewers like you and also in partnership with the following. The Robotics Education and Competition Foundation provides fantastic programs for students from elementary school all the way through college. These include VEX, aerial drone competition, online challenges, JROTC, girl-powered, scholarships, certifications, and so much more. To discover these exciting opportunities, visit recf.org and get connected.
So Aiden, overall, a lot of great stuff going on with this robot here. Talk to me about the polygussets you have going on, and overall, being 10 pounds, there's a lot of challenges that goes into being so lightweight, so tell me more about that.
Yes, sir. So going into this year, we really observed that the meta was changing in VRC overall. We found that a lot of teams were going to start optimizing their robots to be just as fast and nimble as possible, and we wanted to follow this trend as well. So going into our robot, you can see throughout, we implemented these polygussets throughout our robot to just be as lightweight and nimble as possible while still retaining all the rigidity you would have with your normal robot. Going into our drive more in depth, we run 3.25-inch wheels on 450 RPM. We found that this drive packaging really just packaged well with our archetype of our robot, as well as staying very fast with the acceleration as well as top speed that we're seeing a lot of teams use in this game overall. Going into the bottom of our robot, we really, being so light of a robot overall, we wanted to really optimize our center of gravity. To do this, we were able to package all of our main components of our weight in the bottom of our robot, in the bottom 2 inches of our robot. We found that this really helps with acceleration and tippiness and speed as well.
So when you were looking at, this game overall, you mentioned that, changes happen in the meta, I get that, but still designing a 10-pound robot, you have to sacrifice something for it. What did your team have to sacrifice to get this lightweight?
So what our team does that's kind of unique from other teams is that we actually take 3 wide C channels and we cut them down the middle. We call them cut 3 wides, but they're technically just 1x1s that have the exact rigidity of a normal C channel. We found that while this was a lot more lightweight, it still remained just as strong as the other robots.
Yeah, and this back clamp you have is really creative on this. I have to admit, probably one of the more complex ones I've seen out there, so I'd love to have you break that down a bit more. And then we're also going to be talking about how your wall stake, your climb works. Break all this down for me.
Absolutely. Okay, so as Aiden was saying, going into how being lightweight was overall part of the meta, we decided that having a very consistent back mech while also being lightweight was something that we really wanted to focus on. So starting off with our back clamp, just going into how it works and how we designed it, we run 225 milliliter stroke pistons. One of the creative aspects though that's pretty simple is that instead of mounting and fixing our pistons through a pivot on the actual C channel here, we decided to just run it firmly. This is because that incorporates into our geometry of being able to hold the goal in a locking manner. So kind of how to describe it is, you want to turn it on, right? So we're going to activate the clamp real quick. Yeah. So just to kind of go over how it kind of works is whenever we clamp down, the force of the goal is actually exerted vertically into these curved standoffs here. What this allows it to do is allows the force to be transferred into the actual structural element of the robot as opposed to into the strokes of the piston. This in theory pretty much, and in reality, makes it where it's able to lock without the need of any kind of over-center clamp or any other kind of extra piston force. Going on with that, as you can see, yeah, it locks, it does not move at all. So another point that we want to highlight on, especially being lightweight, was being able to incorporate everything at a low CG, as Aiden was saying. As you can see, our brain placement is actually very low. A lot of other teams with this kind of robot archetype will end up running their brain pretty high up say under here, under their chain. But for us, we decided to instead curve these standoffs, which actually, plays into the geometry of the locking clamp, allowing us to keep our brain down here at a very low center of gravity. And of course, with our clamp, we're able to clamp at both at all angles, so it automatically goes to the diamond shape or at the flat end. So going a little bit more into the overall lightweight aspect, as you can see, a lot of the pivots on our pivot points use standoffs that are drilled out as opposed to like a collar. That's something that plays into our lightweightness. Of course, nylon nuts, that's used everywhere else. But overall, just trying to maintain like just shorter pistons, less air consumption, overall plays into just having a very consistent and lightweight bot. Moving on to our high stake mechanism, we decided on trying to make the most reliable and lightweight, especially like with our bracing. So you can see here we have a C channel that's cut out at the base. It still maintains the vertical strength of the wall, but also being, cutting out all the weight that's unneeded. Further, we cut our gears down to be 1/4 inch thickness. Again, just like unneeded weight, cut down as much as possible. As you can see here, we have a rotational sensor. A major thing that a lot of teams run with a high stake mechanism like this is a shaft that goes all the way across. The problem with this is that it's very high up and it's a lot of weight, especially with a high strength shaft. So instead of running a whole high strength across, we're running an aluminum standoff that attaches the two towers together. But we also have a small drilled out high strength shaft that pretty much connects our gear here and a rotational sensor, allowing us to get that sensor feedback while not having to have a standoff or not having a shaft that goes all the way across. And this is just powered by a single 5.5 motor. We originally had this as an 11 watt, or not as an 11 watt, but two 5.5s combining to an 11 watt. We found though that, consolidating more motors towards our intake and conveyor would be more effective, and this 5.5 is still able to yield the exact same result pretty much. And from there, I'm going to go into our hanging mechanism. So this is actually a passive hanging mechanism. It works simply by having a string that mounts to these two 1-bys that pivots on the main cross bracing of the robot. Pretty much all that happens is whenever the high stake mechanism comes up, it pulls the string that pulls up the pulls up the 1-bys, and this is mounted at the exact right geometry for the CG, allowing us to passively just run onto the bar and get the perfect hang every single time.
So to get all this, done as perfectly as you do, are you designing this in CAD or anything like that, or doing any sort of simulations ahead of time or testing either physical or on the computer?
Yeah, so definitely 100%. One of the main things that we wanted to stress as much as possible this year, especially being our senior year, we wanted to incorporate as much as we could into CAD. So that not only goes for our part consolidation of weight, but also trying to figure out the right geometry, especially for the back clamp, which overall helped in the final product of making a 10-pound robot.
And what CAD software are you using?
We're using SolidWorks this year. Yeah, we find that SolidWorks helps, especially in being able to render images and also being able to see the weight totals amount and just the structural rigidity.
Brett, talk to me about the intake. What are you utilizing for that?
Yeah, so as Ian was saying earlier, one thing that we really wanted to stress this year was having a super fast and reliable intake. So whenever we took the motor off of our wall stake mechanism, we decided to isolate the two systems of our intake. Originally, we tried doing this through a double ratchet mechanism, so that way when our conveyor would spin one way, our front intake would spin forwards, and when our conveyor would spin reverse, our front intake would still spin forwards. That way we're constantly utilizing that two-ring mandate, and so this pretty much allowed us to be more reliable with our wall stake scoring, being able to score one, then immediately intake the other one to score it. But this proved to be pretty unreliable with the amount of chain we were running on the robot. So as Ian was talking about, we moved the 5.5 watt down, and this allows us to have a more isolated system. So if we can go ahead and see. Pretty much we can run that, and we can also run our intake by itself. And this allows us to still hold one at a time. With still having the same thing that we wanted with the ratchets of being able to score two wall stakes at a different time.
Are these standoffs doing anything for you, like when the ring is coming through? The
Yeah,
goal?
so these standoffs are just to push the top ring back on our goal, and this is just to allow us still score on our wall stake mechanism, even when we have a full goal, because one of the things we did analyze is you want to be able to hold one of your goals in the last 15 seconds, that way nobody can steal it and put it in the negative corner. So this was actually pretty big on our wall stake plays.
Hannah, something I'd like to ask you about, you have the stick mechanism that's dropping down, but I'd love to hear also more about how this implements into your match strategy as well, too.
Of course. So we have our stick right here, which is powered by a single acting pneumatic piston, which is banded for air retention. And something that's really effective is not only in autos, but it's also effective in autos for goal rush and just different autos, like getting the rings out of the corner. That's what's really huge for us, is getting these 4 rings out of the corner. And we have had multiple iterations of this wall stick. However, we decided this one was the best because it's just so much more efficient and fast. And again, with the manufacturing and the polycarbonate, it's just for lightweightness and everything.
So as we're recording this, we're a few matches in so far for we've been playing. Has that been a factor in your matches so far?
Not necessarily. It's been super effective, and obviously we use it a lot, but it just does the same thing every match.
When it's needed, right?
When it's needed, yeah.
Awesome. Well, 4148Z, thank you so much for telling us about your robot. It's been great to see you all again. So we can't wait to hopefully see a great performance here at Space City and beyond. So thanks for telling us more about this, and good luck the rest of the way. Appreciate it.
Thank you so much.
This video on fun is brought to you by viewers like you and also in partnership with the following. The Robotics Education and Competition Foundation provides fantastic programs for students from elementary school all the way through college. These include VEX, aerial drone competition, online challenges, JROTC, girl-powered, scholarships, certifications, and so much more. To discover these exciting opportunities, visit recf.org and get connected.